One of the most challenging forecasts in cold weather climates is the snow, sleet, freezing rain situation. And last weekend was really the first of those tough forecasts of the season in the Commonwealth. Now, typically this situation occurs north of an approaching warm front where cold air is slow to move out of the way. Warm air coming north runs up and over that wedge of retreating cold air, what we call overrunning. Now, to see how this can lead to different types of precipitation, let's take a look at the situation from the side. Now, you have the wedge of cold air near the ground, temperatures below freezing here, then a layer of warmer air on top of that, and then the colder air on top that's always present at high altitudes in the winter. So you can kind of think of this as a warm air sandwich, and the type of precipitation you get depends on exactly where you are in the picture. So let's take a few slices of this sandwich and look at the vertical profile of temperature. We'll start on the northern side, where there's not much of that warm air aloft. Temperatures in the lower atmosphere might look like this, below freezing all the way from top to bottom. In this case, snowflakes that form in the cold clouds aloft would stay snow all the way to the ground. Now, if we move a bit south in that picture, the snowflakes will have to fall through some of that elevated warm layer, and they'll start to melt. The temperature profile might look like this. Now, typically, if the warm layer aloft isn't too thick or too warm, the snowflakes will only partially melt, and then they'll refreeze in the colder air below into kind of a grainy snow or into sleet, pellets of ice that bounce when they hit the ground. If we keep moving south, the warm layer gets thicker and things change. In fact, if that warm layer is at least a few hundred meters thick, or the temperature is more than, say, 37 or 38 degrees, there's a good chance the snowflakes will totally melt. And when those raindrops fall into the cold air below, that thin layer of cold air, they won't refreeze in the air, but they will freeze when they hit the ground, and that's freezing rain. Now, if that cold air near the ground is really cold, say in the teens or lower, some raindrops can refreeze in the air and you'll get sleet, but that's not very common. And finally, if we move even farther south to where there isn't any cold air near the ground at all, those falling snowflakes melt into raindrops and stay that way. You get a cold rain at the surface, but not a freezing rain. So with this idealized model in mind, you often find all four types of precipitation as you move across a warm front. First rain, then typically narrow bands of freezing rain and sleet, and finally snow as you get deeper into the cold air. Now, in reality, it's almost always more complicated. There might be places where precipitation mixes, maybe sleet with snow or sleet with freezing rain, and cold air trapped in valleys, as often happens here in Pennsylvania, just makes the forecast all that more complex. Stay tuned. Paul will tell us if any more of these type storms are in our future in the extended forecast.